the event, participants submitted any questions they had for our panelists ahead of the webinar. We will be asking our panelists these questions, but if any of our participants have any questions that come up while they are listening, we encourage them to send those to us using the chat function. Our first question is directed towards Ms. Sharshonov, and it comes from a grade 10 student from Fort Richmond Collegiate. And it is, if I were to take AP courses in high school, could you give some suggestions on which ones to take, such as chemistry or biology, etc.? Or do you recommend taking AP at all?
So it all depends. As far as I'm concerned, I know when I was in high school, when you were taking the AP biology and AP chemistry, just the way it was working, just the content that they had, when people were taking, like if you're taking it just to learn more, then by all means, I recommend to take AP biology, AP chemistry, depending on the field you want to get into, if particularly pharmacy, definitely. Calculus, I 100% recommend because you work so closely with the professor, you have a high chance of doing well. But I know that when you AP biology and AP chemistry, if you decide to challenge and take the university exam to try and get a credit for university, I know at the time most students didn't have as much luck getting the higher A's and A pluses to reach a higher GPA that they wanted in order to get into pharmacy itself. But if you want to take it and not take that university exam, but just take it so that you have a good solid foundation for the biology and chemistry, by all means, because the courses that you'll be taking in university, like I said, you'll have a lot less interaction with the professor and it'll be a lot of self-teaching. So if you can have a base, it would be good.
Perfect. Thank you for that response. Now, our next questions are for anyone to answer. So any one of you panelists may answer, or all of you may answer if you'd like. It comes from a student in grade 9, and they ask, what was the most difficult decision you've had to make in your career?
I can answer that, at least for myself. I know my parents were not that, they were very open and they let me choose what I want to do, but there was a lot of social pressure to go into medicine. And I had to simply follow my passion to be a researcher. And I'm very happy that I made that decision at that time. So today, when I go to work, it's fun for me, not really work.
Is the question directed at all three of us?
If just one of you would like to answer, that's fine too, but you may answer as well, yeah.
I guess for me personally was trying to decide between personal and career-wise, quitting my pharmacy job that I was super happy getting and I was content with for my own reasons to find out those things. That was a difficult point. But besides that, getting into and finishing the schooling definitely is always, yeah.
And I'll take a crack at that question as well, but I'm going to answer it slightly differently. I really didn't make any decisions about my career path. Scientists are supposed to be very logical and planners and organized, and I can do that, but I'm also a Pisces, so I'm a bit of a hopeless romantic. And most of the key decision points in my career were based on following my girlfriend somewhere. So I finished my PhD when I did because the person I was dating at the time moved to Toronto, and I really had to finish my PhD if I was going to be with her. She completed her schooling in Toronto, moved back to Montreal, so I followed her to Montreal to start my second postdoc. And then she dumped me, so I was on my own for a while and had to make some choices. But then since then, the person who's now my wife, I followed her to Regina, and then I followed her to Winnipeg. I've managed to make it work, but it's really not a path I would recommend. So if you're out there thinking about what you should do, you need a plan. You should be flexible. You should be able to weather the inevitable, hits that come with whatever you do, but start with a plan. I know when you're in high school right now, you're thinking, okay, what university can I get into? Which courses do I need to take to get into university? All that kind of stuff. Your focus shouldn't be so much on getting in. Most of you out there are probably smart enough and have good enough grades to get into whatever sort of bachelor's program you want to get. The trick is, what do you want to get out of that? Where do you want to be? What do you want to learn in that program in order to get you to the next stage of your life? Because, even in the time that I've been through school and everything, things have changed so much. I went to school, when I was in university, things were still relatively cheap. My tuition for my first year of university, which was back in 1994, was only $900 for all of my classes. Whereas now you are paying, thousands and thousands of dollars every year. And so unless you have a plan at the end of that, and it's something that is going to eventually pay those bills, you need to figure that out. One advantage of sort of graduate school and PhD program is if you're in a science thesis program, you normally make a stipend. So you actually get paid to go to school. It's not a lot, but if you're, single and in your 20s and don't have kids, it's enough to pay your rent, to pay your tuition. And since you're going to be living at the lab anyways, you only need a little bit of money for your social life. However, if money is an issue, that's also something that you have to be aware of. A lot of the professional programs, be it pharmacy or medicine or anything like that, you pay a lot up front with the expectation that when you get a job, you'll be able to recoup all of that. But you just have to be aware of what you're able to do, what you're able to manage, and where you want to be. And that's actually often a common question. Where do you want to be in 5 years? I've never really had a good answer to that one, but before you invest a lot of time and money in some program, figure out where you want to be after that program's over, and that can help make you decide. I think a university degree, it won't hurt you. It's a great place to spend 3 or 4 years and find yourself, but times have really changed, and for example, a Bachelor of Science on its own probably isn't going to get you where you need to. It might be a prerequisite for getting into a professional school or med school or something, but you're going to have to do more. And there's actually a whole lot of life science college programs out there that will only take 2 or 3 years to do and pretty much guarantee you a job. So if you're not in it for a long haul, a program that's going to be your 3 or 4 years of bachelor's degree plus 2 or 3 years at least of schooling after that, look into the life science college programs, and there's a lot of good ones out there. I mean, the one I'm most familiar with is the medical lab technologist that will get you into a hospital lab or a public health lab or some other laboratory profession. But you can be done by the time you're 23 or 24 and making $50,000 or $60,000 a year, as opposed to being, $50,000 or $60,000 in debt when you're 25 or 26.
Yeah, I'll add to it. And I'm a Virgo, and I plan a lot, but things really doesn't plan out as you plan them. So the take-home message here is your background preparation should be really strong. And I totally agree with Dr. Alexander that going to the university and take an undergraduate degree and do well and choose your subjects carefully where you want to go and plan that. Talk to your student counselor. They can help you in deciding what kind of subjects you would like, what kind of subjects or courses you should take, and that's certainly going to help you. Yeah. And there are courses like radiation therapist. They make pretty good money as well. And that is through Red River College. Physician assistant program is a very good program where you almost make like $80,000, $90,000 a year. And now we have I think we have a dedicated program for physician assistant here in Manitoba. And they all require life sciences courses as prereq, I guess.
Great. Thank you so much for sharing those decisions and for also sharing some wise words. Our next question is, again, a general question for everyone. It comes from a grade 10 student from Sisler High School. And their question is, how has research and development changed during your academic or professional career? I know that some of you had touched on this already, but if you could go more in depth, that would be great.
Do you want me to start the discussion? Oh, research has changed over the period of time so much. And in past 20 years or 15 years with advancement in computing technology, we have made so much of progress that you can see now the whole genome can be sequenced using, a device which is as small as your cell phone. So we have made real good progress there. There are various areas, and now we have also, crossed boundaries. There's so much of interdisciplinary research nowadays. You cannot do research anymore in your own silos. You have to go out and collaborate with people who have got other kind of expertise. Who would have thought, you can use math in biology, you can do math biology. I can give you an example. We have a side project where we are developing some algorithms to essentially make artificial pancreas. And it's not that it sounds very cool, but there is already a continuous glucose monitoring system available in the market, and there is already an insulin pump. It is just how you make that a closed loop system, and that's artificial pancreas. So one of my grad student is in fact he has all his training in math, and he is developing mathematical models so that we can precisely calculate how much insulin has to be given, just to give you an idea. So the research has progressed so much nowadays. You can actually take a patient and do the whole genome sequencing and decide what kind of treatment you would give to that patient. So yeah, it's very cross-disciplinary, and in my view, future is going to be in computational biology.
Okay, thank you, Dr. Shrivastava, for sharing your thoughts. Our next question is directed towards Dr. Alexander. It comes from a student in grade 12, and they ask, what can a career in public health look like?
So there's lots of different ways to do a career in public health. It's a very, very broad discipline that includes everything from social work to the kind of work I do. And the main reason I didn't do it was because I didn't really want to deal with people a whole lot. And I only later learned about all the many, many disciplines within medicine where you can do more research. In my lab, our medical director, he's what's called a medical microbiologist. And so it's basically a doctor who specializes in the laboratory side of science, whereas there's a separate discipline for infectious disease doctors, who are the people who actually, go and see and treat your infectious diseases. Public health, there's a lot of epidemiology. And as was just mentioned, there's more and more computers involved. So there's entire disciplines for mathematical modeling of infections. And through COVID, we're seeing some of that. People who are predicting it's like, if we do the lockdown now, there will be this many cases in 2 or 3 months, versus if we lock down in 2 weeks, there'll be twice as many. And modeling is actually a lot more than guesswork. I'm like, it's not just somebody making up a graph and saying, oh, this is how it's going to work. I've historically been very, very suspicious of it, but I have a colleague who's a mathematical modeler, and back in August, he's like, you might be having a really nice summer in Manitoba right now, but by October, November, there's going to be so many cases. And we're like, yeah, the weather's beautiful and everything's working out fine. And sure enough, his predictions came through. A lot of the people that I work with they're trained in epidemiology, and there's a variety of ways into the epidemiology programs. But again, these are people who study the spread of diseases from the people side of the equation. I'm always very focused on the bacteria and the viruses themselves, whereas on the other epi side, it's looking at the numbers of people involved. And it doesn't only have to be infectious diseases. It can be cancer, it can be heart disease, it can be all these other things. So there's many, many routes. And it's hard to think of a discipline that you can't somehow find a public health component of it. It's really just an application of a set of tools to studying how diseases work or conditions work within the population.
Great. Thank you, Dr. Alexander, for telling us about those specialties in public health. It sounds like a very intriguing field. Our next question is from a grade 12 student, and it is a general question. What made you decide that your career is right for you?
I can start I can get this rolling. I think, I don't know if there's an exact point in time where I realized it was right for me. But I guess once I was out there working and seeing the impact that my knowledge and my education and my caring can have on patients, for me was what I realized I connected with the most, knowing that I am there to be trusted by these patients, and I'm there to help them take care of their health, to better their health. And you recognize your influence. But that being said, that can be different for everyone else. It all depends on what your passion is for. So I guess it's the lining up of your passion.
I always knew that I wanted to be a scientist, and I'm very fortunate to be doing what I always dreamt of. But it's a very long, tiring journey, believe me. So nowadays, I tend to tell my grad students and postdocs that it's better to get a nursing degree and then do PhD, so that you can become a faculty member way sooner than actually going through the traditional route. So that is a very good option. Like, you can do nursing and then do a graduate studies in nursing, and there are a lot of nursing faculty positions are available. And to be a nursing faculty member at a university, you need to have at least one nursing degree and a nursing certificate. So you don't find that many, candidates with both nursing and PhD degrees. So that's a good alternate route.
And I have to echo that. I laugh when you say go into nursing, because if people approach me, I say go into medicine. If you're going to spend, 7 or 10 years in university, you might as well, get a medicine degree, because it is a route into doing clinical research and that sort of things. And if the research doesn't work out, well, you've got a really good paying job to go back to. And if people ignore that advice, then maybe they actually are suitable for graduate school because they're stubborn enough and they're going to work hard enough and be focused enough to get through the process. As far as, when did I know that I wanted to do what I want to do? It was a process that kind of evolved, because I knew from my undergrad days that I really liked microbiology and I really liked lab work. When I was in my 20s, I loved the student lifestyle. I did it as long as I possibly could. From the time I started my BSc to the time I finished my postdocs, I'd been in university for 17 years. And one of the reasons I had to get out was I realized that the people who were starting their undergrads were born the year that I started university, and I'd probably just been in school for too long. As far as public health, a lot of that happened during my postdoc, where I became increasingly aware that even though we were studying this Mycobacterium tuberculosis organism and it causes terrible disease, we'd finish every paper saying, oh, this research will help us find a vaccine or find a drug or help us treat the disease. But in a lot of ways, infectious diseases aren't about the organism so much as about the person. And it's really the social determinants and age and other things. Yes, you'd stay well and healthy and alive if the bacteria or whatever wasn't there, but there's so many lifestyle issues. And that's, we've seen that especially with COVID, the impact it's had on nursing homes and certain disadvantaged populations, all that sort of stuff. If you're otherwise young and healthy, yes, you may get sick, but chances are you'll eventually shake it off and be fine. And so many of the measures we're taking are in place to protect those who won't have good outcomes. And that's true for all diseases. So the nice thing about public health is, as much as there's about this science and research component, there's also this idea of harm reduction and trying to find better ways to do things to help more people. And I like that blend of both the head and the heart that goes into it.
Great, thank you so much, all of you, for providing those perspectives. A reminder to our participants that they are encouraged to ask questions in the chat, and we will be sure to consider them. Our next question is a question delivered through the chat, and this student asks, what do you analyze when turning an unsuccessful project into a new research question? And what was your experience with that? How did you deal with that failure?
There's a lot of ways to answer that, but I'll take a shot. I mean, part of it has to do with understanding where the failure came from. Sometimes the question you're asking is just not the right question to ask in the first place. And sometimes it's because it's a perfectly decent question or line of research, you're just approaching it the same way. And so it really, I think part of it is a little bit of introspection to go back and look at things. And the exact outcome depends. So, I mean, during my first postdoc, my supervisor asked me to study this organism that was sort of a pet project of his. He'd done something called chemical mutagenesis, and basically that means mutating the DNA in the organism, and it suddenly was behaving very, very differently. And he wanted to know, how come the original strain behaved one way and this other strain behaved a different way? And I did try this project for several months. And at some point I just realized we're never going to figure this out, because the way he had made the mutations in the first place, it's like shooting somebody with a shotgun and they've got bullet holes all over their body. And it's like, well, which one killed them? It's like, well, there's not really a good answer because you've got holes everywhere. And we weren't going to be able to narrow down which specific mutation was causing these changes in this organism because there were just so many. So what I did is we went back to the drawing board, and it's like, okay, rather than working with the strain you want, we're going to take a fresh strain and we're going to make mutations in it, but we're going to do it in such a way that we're only making one mutation per organism. And then we're going to screen thousands and thousands of these until we find something that has that same, what we call the phenotype, those characteristics you found the first time. And that actually worked really well because we only had to find the one defect. We didn't have to sort through hundreds or thousands that he'd made the first time. Plus, in screening this library, we found all of these other things we'd never seen before, and we're able to then have all these additional research questions to go after. And one of the ones we found that we couldn't even have imagined creating or finding actually turned into the main work of his laboratory, and kept his students busy for the next 6 to 8 years. So I guess I'll stop with that example. I'm sure the others have many.
I can tell you that in our line of work, you encounter more failures than success. And I tell my grad students, like during weekends after our lab meetings, we'll have beer, but then most of the time you will be crying over your failures. And there will be only few when we will be really celebrating. But it's all, I can tell you, it's all about going back and looking into your, whole, looking into what you have been doing. And the key thing here is maintaining your lab notebook. And just to emphasize that, I tell my grad students, like, even if you have taken a break to go to a washroom, make sure you note that down in your notebook so that we know that there was this time lapse there. And we have actually, this has happened to us where the project totally crashed. We didn't know what to do. And in fact, when we look back, we discovered something very fascinating. And I can tell you that story in it's a, if you let me do so, if it's okay, I'll take a minute here. So we made we took a cancer cell line. So it's like cancer cells. We made some mutations. And there is something called fax machine where you sort those cells. And those lines were clogging the fax machine. So the technologist said, something is wrong with your cell line. It's clogging our lines. And my grad student was so upset because he has been working on that project for so long. And he said, it's not working. It's a fluidic system, and very, there's these capillary tubes, and they all were getting clogged. And I was getting excited. I said, do it again. So he did it again, came back, and he said, you know what, it's clogged again. I'm like, that's good, do it again. So after 4 trials, he was really mad at me. And he said, I don't know what you want out of this, but these the parental cells are doing all good, but this mutation is making all these cells clogged together, and it's clogging the tube. And that's when we discovered that we were actually making them more, how to explain it to you guys? Like, it's basically, you're making those cells which could simply float around, but now they're all coming together. That means you did something there. That mutation has made those cells to stick to each other, which is a very good thing in cancer. So if you do those mutations in metastatic cells, metastatic cancer, you're making them back to primary cancer cells, which are very easy to treat. So we are about to we are about to file a patent on that. And that was an amazing discovery out of a failed project. So it's always good. Even you should have this habit to maintain your notebook very religiously. Note down everything if you're doing any experiment so that you can always go back and check what's wrong in there.
No, that's a great story because it highlights the old phrase that luck favors the prepared mind. I mean, in microbiology, one of the most famous stories, and I don't even know if it's true, but it's a great story. But the discovery of penicillin has to do with Fleming, who discovered it, went away on holidays and had some stuff left in his lab. And when he came back, it was all moldy. And rather than throwing out the moldy plates, he looked at them first and noticed one, that there was a clearing around the mold. There was no bacteria growing anymore. And he put two and two together and realized that mold is making something that's killing the bacteria. And from that was the beginning of penicillin. So yeah, to be aware of what's going on and keep good notebooks, so that you can always go back and figure out what's different this time and what do I see that might make a change and allow us to move in a different and more productive direction.
Great. Thank you so much, the both of you, for sharing those stories and those valuable insights. Our next question is, do you have any research opportunities or advice for high school students in mind?
So I have had high school students in my lab to do some research project. And I always believe, and I have been judged to many of these, research competitions or research exhibitions, science symposiums and science exhibitions. What I really like is you should come up with your own ideas. If you have, and many a times it's not the complexity of the experiment. Very simple experiments can give you very vital information. So think about those. If you have any ideas that you want to, uh, come and use our facility for that, I'll be very open to it. We do have, I have my own research program where I encourage all undergrad and grad students to take part in. High school students, if they are interested in pursuing specific research questions, they're more than welcome if I can provide those kind of facilities to them. Or sometimes they can come with their research question and we can discuss and actually design a project out of it. So yes.
And I'm in the opposite position because I work in a highly regulated government facility where every day we're testing thousands and thousands of patient specimens. And, we don't really have a good place to put students who are simply looking to learn. That said, it's mainly geared towards university students rather than high school students, but there is something called the STEP program where the government does provide a stipend to work in our lab. Now, most of the time you're not doing particularly interesting things. It's sort of like the blister pack story, but at least you're in that environment and you get a sense of what goes on a day-to-day basis, and you might from that be able to figure out, is this a place you'd like to work? Is this the kind of work you'd like to do? A lot of I find my job really fascinating because I get to kind of pick and choose the most interesting outbreaks and organisms to really follow up on. But a lot of what we do is very repetitive. Since last February, we've done 225,000 COVID tests and we've done 100,000 HIV tests and on and on and on. So it's a lot of the same thing over and over, but it is still, quite important work. And there's always some troubleshooting to do or something weird that comes up that you've never seen before. So it's not necessarily boring, but there's a lot that is the same.
There's another program that you guys should keep an eye on, especially if you're a first year or second year undergrad student. It's called co-op program. So go and check. I don't know whether it's for high school students or not, but for first year, second year student, you can certainly do this co-op program.
All right, thank you for sharing that with our audience. And we have now come to our final question, which is, if you weren't studying in your current field, what would you be studying instead? Did you have strong interests in other fields?
I would have been a lawyer. I always liked those crime scene series, and I thought that it would be good to become a criminal lawyer. I like the legal stuff. Yeah.
If I could do anything, I'd be a rock star, but it's not really a viable option for me. I'm just not that good with the instruments I have. But a realistic one would be computational biologist. So more and more, rather than working at a bench doing, kind of lab work, I'd be perfectly happy in front of a computer developing algorithms and analyzing data. And there's actually a huge need for that. I mean, historically, I used to joke that, I was a biologist because I couldn't do math, but more and more, you need to have some biostatistic skills and mathematical skills and the ability to run computer algorithms to do a lot of the work I'm doing now. Yeah, and it goes both ways. I know biologists who have switched to become computer scientists, but I also know some computer scientists who've got into biology and genetics, and they become really complementary in fields together, even though in some ways they're so different.
I think for me personally, I've always really liked psychology as well, and then the further I've gone into pharmacy, the more I start to learn about mood disorders, and it's always just been a very interesting topic for me. So potentially psychiatry or psychology or something of that sort. Well, I've always found that interesting, but it's also a lot of school to do psychiatry. It does require you to go through med school, so I don't know if I'm going to turn that path at this point in my life.
Great, thank you for those answers. This next question is directed towards Dr. Shrivastov, and it is, how did you make your decision on science versus law?
Oh, law is my recent passion. So I was always drawn to legal stuff, I think from my high school onwards, but passion for science was deep rooted since my primary school. So I could easily make that choice. And I think that at some point of time, I would still like to go back to school and probably go to law school. It's not just, and there's so much of opportunities in law as well, where you can be a scientist and become a lawyer. You can do law in intellectual properties related to biotechnology. Yeah, I hope I answered that question.
Yes, I think you answered it really well. And I know we said it was our final question a while ago, but this is definitely the final one. And it's for Miss Sharshonov. The student asks, where can a high school student go if they would like to have experience in a pharmacy?
In terms of high school student, I believe, I'm trying to think if, I don't recall in high school I had an opportunity to do a day or something working or shadowing a pharmacist. I don't know how career days work nowadays, especially not with COVID. But potentially reaching out to any pharmacy, any local, independent, or shop or superstore, any of those sort. I'm sure there's some way to even do like few hours just to shadow a pharmacist and see what it's like. In terms of actual work, you could apply to be a pharmacy assistant. Um, so it's not a tech nor a pharmacist, and you get to work in a pharmacy and get exposure to it. I know people in university have done that prior to pharmacy, and I don't know if per se they worry what like you would need to be over 16, or I don't think you need to necessarily be in university, but I would have to you'd have to double check that.
Great, thank you so much, Ms. Sharshonov. That was our last question. And so with our first professional panel of 2021 now coming to a close, on behalf of Project Pulse Winnipeg, we would like to send our sincerest thanks to all of our amazing panelists for taking the time out of their busy schedules and sharing their insights, experiences, and answering all of your wonderful questions. We are very fortunate to have such distinguished speakers from such a wide variety of positions within the health sciences. So thank you so much again for bringing your expertise to the table and engaging in such an inspiring discussion with our audience.
Thank you for having us.
However, in addition to our wonderful panelists, all of you in the audience deserve a thank you too. So we would like to extend our heartfelt thanks to all the audience members, so all of the motivated high school students and dedicated post-secondary students for actually making this event a success by registering to attend. Moreover, thank you to all of those who took the time to think of an insightful question that stimulated a great discussion. All of you are the reason that all of us on Project Pulse are inspired to continue to create online events. So thank you so much.
All right, and also a massive thank you to Rhea, Miguel, and Boke for hosting this. That was a wonderful panel, and Project Pulse Winnipeg immensely appreciates our honored guests for their time and the gift of their insights. Just a reminder to those of you who have your video cameras on to please fill out and return your waivers, and we hope to receive those emails promptly. Looking ahead, we recommend you follow us on Instagram and Facebook to stay up to date on when our upcoming events are happening and how you can get involved with the organization. Our fancy website, managed by Eagle, our graphics designer on the team, is also a good place to find more information about Project Pulse Winnipeg and access links to these panel recordings. We challenge you to bring a friend or a classmate to our next event and hope to see all of you again next time. Well, take care, everyone, and have a good evening.
Thank you.